Question 1. A company needs to ensure its primary relational database is highly available with automatic failover in case of an availability zone outage. Additionally, they need to scale the database's capacity to handle a high volume of read queries from analytical applications. Which two Amazon RDS features should be implemented to meet these requirements? Option A. Multi-AZ deployment for high availability and read replicas for read scaling. Option B. Read replicas for both high availability and automatic failover. Option C. Automated backups for disaster recovery and multi-AZ for read scaling. Option D. DB snapshots for data protection and parameter groups for performance tuning. The correct answer is multi-AZ deployment for high availability and read replicas for read scaling. Here's the explanation. Multi-AZ deployments provide synchronous replication to a standby instance in a different availability zone, ensuring high availability and automatic failover. Read replicas are designed for scaling read-heavy database workloads by providing asynchronous copies of the primary instance, offloading read traffic. Question 2. A database administrator has provisioned an unencrypted Amazon RDS PostgreSQL instance and now needs to enable encryption at rest for compliance reasons. What is the correct procedure to achieve this? Option A. Modify the existing RDS instance and enable encryption directly from the AWS Management Console. Option B. Stop the instance, enable encryption, and then restart the instance. Option C. Create a DB snapshot of the unencrypted instance, copy the snapshot enabling encryption, and then restore from the encrypted snapshot to a new RDS instance. Option D. Encryption at rest is automatically enabled for all new RDS instances by default, so no action is needed. The correct answer is create a DB snapshot of the unencrypted instance, copy the snapshot enabling encryption, and then restore from the encrypted snapshot to a new RDS instance. Here's the explanation. The study material explicitly states, you cannot encrypt an unencrypted DB instance after creation. You must create a new encrypted instance and migrate data. The recommended method involves creating a snapshot, copying it while enabling encryption, and then restoring from the encrypted snapshot to a new encrypted RDS instance. Question 3. An application processes high-volume, I/O-intensive online transaction processing (OLTP) workloads and requires consistent, predictable performance from its Amazon RDS database. Which storage type is best suited for this specific requirement? Option A. General Purpose SSD GP2 GP3. Option B. Provisioned IOP SSD IO1 IO2 Block Express. Option C. Magnetic. Option D. S3 Standard. The correct answer is provisioned IOP SSD IO1 IO2 Block Express. Here's the explanation. Provisioned IOP SSD IO1 IO2 Block Express is specifically designed for I/O-intensive transactional (OLTP) workloads requiring consistent high performance. General purpose SSD is suitable for a wide range of workloads, but may not provide the consistent high performance needed for the most demanding OLTP scenarios. Magnetic is a legacy option, and S3 Standard is an object storage service, not an RDS storage type. Question 4. An application requires extremely high availability for its relational database and cannot tolerate any data loss during an unexpected database instance failure or availability zone outage. Which Amazon RDS feature is specifically designed to meet these requirements? Option A. RDS Read Replicas. Option B. RDS Multi-AZ Deployment. Option C. RDS Database Snapshots for Point-in-Time Recovery. Option D. RDS Performance Insights for Query Optimization. The correct answer is RDS multi-AZ deployment. Here's the explanation. The overview and key features/components sections clearly state that RDS multi-AZ is primarily designed for high availability and disaster recovery, using synchronous replication to ensure zero data loss and automatic failover during an AZ outage or instance failure. Question 5. What is a key difference in the replication mechanism and potential for data loss between Amazon RDS multi-AZ deployments and RDS read replicas? Option A. Multi-AZ uses asynchronous replication with potential data loss, while read replicas use synchronous replication with zero data loss. Option B. Multi-AZ uses synchronous replication with zero data loss, while read replicas use asynchronous replication with potential data loss. Option C. Both multi-AZ and read replicas use synchronous replication and guarantee zero data loss. Option D. Both multi-AZ and read replicas use asynchronous replication and have potential for data loss. The correct answer is multi-AZ uses synchronous replication with zero data loss, while read replicas use asynchronous replication with potential data loss. Here's the explanation. The key features, components, and exam tips sections explicitly state that multi-AZ uses synchronous replication, RPO equals 00 data loss, whereas read replicas use asynchronous replication, meaning there can be a slight delay and potential for data loss if the primary fails before changes are replicated. Question 6. A company operates a popular news website that experiences heavy read traffic, especially during breaking news events, but also requires its primary database to be highly available. Which combination of Amazon RDS features would best address both the high availability and read scalability requirements? Option A. Deploying a single RDS instance with multi-AZ enabled. Option B. Creating multiple read replicas from a single AZ primary instance. Option C. Deploying an RDS primary instance with multi-AZ enabled and creating one or more read replicas from it. Option D. Using only a single AZ primary instance with a very large instance type. The correct answer is deploying an RDS primary instance with multi-AZ enabled and creating one or more read replicas from it. Here's the explanation. The exam tips and comparison/related concepts sections highlight that you can create read replicas from a multi-AZ primary instance. This provides both high availability for the primary database, multi-AZ, and read scalability, read replicas, for read-heavy workloads. Question 7. Which statement accurately describes a key architectural differentiator of Amazon Aurora compared to standard MySQL and PostgreSQL databases? Option A. Aurora uses traditional file system storage directly attached to the compute instance for superior I/O. Option B. Aurora separates its compute processing layer from a distributed, shared, log-based storage service. Option C. Aurora relies on manual storage provisioning and scaling up to a maximum of 16 terabytes. Option D. Aurora is a NoSQL database engine designed for unstructured data, unlike MySQL and PostgreSQL. The correct answer is Aurora separates its compute processing layer from a distributed, shared, log-based storage service. Here's the explanation. Amazon Aurora's unique architecture separates the compute and storage layers, utilizing a distributed, shared storage service that is purpose-built for database workloads. This allows for independent scaling, superior performance, durability, and availability, and is a core differentiator from traditional relational databases. Question 8. An application requires a database solution that can automatically scale its compute capacity based on demand, shut down when not in use, and is cost-optimized for intermittent workloads. Which Aurora feature is best suited for this requirement? Option A. Aurora Global Database. Option B. Aurora read replicas. Option C, Aurora serverless. Option D, Aurora backtracking. The correct answer is Aurora serverless. Here's the explanation. Aurora serverless is an on-demand, auto-scaling configuration for Aurora that automatically starts up, shuts down, and scales capacity based on application demand. It's perfect for intermittent or unpredictable workloads, optimizing costs by only paying for the exact capacity consumed. Question 9. Regarding data durability and availability in Amazon Aurora, how is data replicated within an AWS region? Option A. Data is replicated 2 ways across 2 availability zones. Option B. Data is replicated 3 ways across 1 availability zone. Option C. Data is replicated 6 ways across 3 availability zones. Option D. Data is replicated 4 ways across 2 availability zones using local SSDs. The correct answer is, quote, data is replicated 6 ways across 3 availability zones. Here's the explanation. Aurora's distributed, fault-tolerant, self-healing storage ensures high durability by replicating data 6 ways across 3 availability zones. This provides protection against data loss, even in the event of an entire AZ failure. Thanks for watching. Please subscribe to my channel.